So I'm Marco Remme. I am the sales director for Nordics and Baltics for Gigamon. I actually joined May last year, fairly new. With me I have Pete Connolly, our sales engineer, working with me here in the Nordics and Baltics. And he's actually going to do a bit of demo. And I know we've been running for 1 hour already. I'll do a few slides, give you a proper introduction to Gigamon, who we are, what we do. And then we will move into the demo. And actually, Pete's lab, he's going to show a demo including Vectra. Okay. To continue on the question from online, I think it was, that Vectra was talking about. When I talk to CISOs today, I ask them, what are your top priorities? Typically, I hear eliminate blind spots. Like zero trust projects are pretty common today. But if you have blind spots, if you don't have complete visibility into everything, how can you be successful with a zero trust project? It's impossible. And yeah. Quick hands up. How many of you have heard about Gigamon before today? Quite a few, actually. Maybe because you're a ByteLife customer. So I'll kick off. Gigamon is turning 20 years today. A very proven technology. 2 years ago, I had not heard about Gigamon, believe it or not. I was selling an OT tool to a Danish power giant. And they said, yeah, we will buy your tool. I was with Forescout then. It's like similar OT capabilities as Nozomi or Armis or Dragos or Clarity, those guys. So I was selling that. And I said to them, so why don't you buy now if you're going to buy my tool? And they said, well, we will buy your tool, but we need Gigamon first. And I was like, yeah, of course you need Gigamon first. I leave the meeting room, I Google, what the heck is Gigamon? And here I am today. So, the slides are not moving. Where's the clicker? Ah. There we go. All right. So, Gigamon. One of the things that surprised me 2 years ago is that more than 80% of the Fortune 100 companies run on Gigamon to increase their security posture. More than 80%. It just shows that Gigamon is a proven technology, that the largest of companies and organizations run on Gigamon. 9 of the top 10 mobile network operators run on Gigamon. Very complex, tons of data points, of course. Healthcare, love Gigamon. What I'm proud about regarding this slide is actually the very high customer satisfaction rate. Whenever I meet with customers that have been running Gigamon for some time, they say that it just works. On-prem, it just works. Cloud, it just works. So Gigamon is really a software company, but to give you some background on what we actually do, I will go back to like 20 years and then talk about it, explain what we do. So Gigamon innovation, how it started. What you see here is the traditional infrastructure map. It looks like this. And you have a lot of different tools. Most tools use agents because they need to understand what is moving on the network. So those tools use agents. The problem is, over time, you have one headache, you buy one tool. You have another headache, you buy another tool. Over time, you have multiple tools. The problem is there will always be gaps between multiple tools. Problem with multiple tools is also that you need more people to monitor and look into all your tools. Those agents that collect data to those tools need to be patched. Patch, patch, patch. That's one of the things CISOs say. They are fed up with the amount of tools they have and the patching that is required. If you remember the infamous breach, 2018, I think it was, Equifax, they lost some 400 million personal records. They were running 12,000 servers. Those servers had some Apache software. That Apache software had a known vulnerability. So they went on and patched them all. But they missed out 2 servers. That's where the breach happened. So Gigamon came up with this invention, simply put. We use network taps, or in the cloud we use what we call container taps or virtual taps. But what we do is we take one copy of unique events and then we can send it to multiple tools if we want. This removes, tools will still use agents, but this removes a lot of the infrastructure complexities that you see on the left picture. Now, we are a software company. In that Gigamon box to the right, we have now hooked up the Gigamon tools, your investments already made, your existing security tools hooked up to Gigamon. And in the Gigamon box, or Gigamon software, if it's cloud or virtual, the magic happens. First of all, someone is emailing from home office, that can travel through several switches. Gigamon will look at it and say, hey, this event we already saw 2 seconds ago. We don't need a copy. We do deduplication. Only by doing deduplication, we can reduce the amount of traffic hitting your existing security tools by some 50%. And then we can do other things, like someone starts a Teams meeting. We want to know who started it, what time, and so on. This is called metadata. Who is joining the meeting? When did the meeting stop? But we don't need a video or visual itself. No need to store that. We call it filtering, take it out. So by using certain technologies, we can reduce the traffic hitting your existing security tools by some 75, 80% on average, which is pretty amazing. I also mentioned there will be gaps between different tools. With Gigamon, we eliminate blind spots, whether it's on-prem, virtual machines, private cloud, public cloud. We make sure that we eliminate your blind spots, your shadow IT. And then feed your existing security tools. So, to give you an example, if you look at this noise coming into the Gigamon box from those network taps, we can start doing things like flow mapping. This data is only relevant to these different tools. Maybe the Steam tool for correlation, maybe Tenable, and then Nozomi, I'm just making up here. So we can start doing flow mapping. We have one copy, we can send it to multiple tools, but only send it to relevant tools. Avoid bombarding your existing tools with rubbish. We can do deduplication, as I described, application filtering, and eventually you will have a very, very strong signal hitting your tools, i.e., like making Vectra better, making Elastic better, instead of being bombarded by rubbish. And as the Vectra team were talking about it, they OEM Gigamon to be able to send to understand traffic in cloud, like Azure, and then can send that data to your existing familiar on-prem tools, for instance. So we increase the security posture. Cost benefits comes like a side effect of what we do. Now, if you think about it, if you can reduce the traffic hitting your existing tools by 80%, that comes with certain benefits. Like, enterprise customers, they typically expand their network with some 10 to 30%, let's say 15%. Expansion of network means more data points, and you will need to expand also your license base on your existing security tools. More license means also you will need to run it on servers. Servers require power and cooling. Now, what if you can reduce noise hitting your existing security tools by 80%? That license expansion that you already have approved for 2024, you can postpone that expansion, maybe some 3-4 years, because suddenly you're reducing the amount of traffic hitting your tools. Which also means suddenly your servers are not going so hot. You need less power and cooling. I typically say there's always a Gigamon story to anyone, even the facility manager, because they often pick up the electricity bill. And if we reduce, we have actually studies that Gigamon customers see that the power and cooling goes down by some 5 to 10 times on the existing security tools. Make sense? Like Vectra, we also have a lot of integrations. If you read the names here, I'm sure you are familiar with some 90% of the tools maybe. There are OT tools like Nozomi and Armis and Forescout, Tenable. We have different tools. These integrations, more than 130 kind of out-of-the-box integrations, we do this magic towards those tools. And these tools, these vendors, they actually love working with Gigamon. And we just saw that 3-4 weeks ago only. It was a big announcement. Vectra and Gigamon signs this OEM agreement. So you will get Gigamon as part of Vectra solution to get visibility into cloud. So, one of the challenges when I talk to CISOs is OT used to be a silo, but it's not anymore. Some call it Industry 4.0, some call it digital transformation, move to cloud, but the OT, operational technology, is your manufacturing facility, for instance, your conveyor belts, robotic arms. You used to have an OT security manager. That's not the case anymore, because automation of manufacturing and process industries will drive tons of IT and IoT devices in the traditional OT domain. Suddenly, everything is becoming interconnected. Which means OT traffic will hit IT tools, which means rubbish. IT traffic will hit OT tools, which is rubbish again. So with Gigamon, we can make sure that relevant data only hits relevant tools. Make those your existing security tools, your existing investments, make them better, get more value from them. Private and public cloud. Hybrid network visibility gaps. So today's network security posture focus on traffic entering and existing on traffic entering and exiting segments, which means you are blind to what we call east-west traffic. So once you have your perimeter in, perimeter out, the traffic in between is called east-west traffic. It doesn't hit segments or switches or firewalls, anything like that. So what is east-west traffic? Like, if I book a hotel, I am kind of booking it. The booking.com or whatever will then look in a database for available hotels in that city, what rooms are available. Then suddenly I also get the promotion. You get 20% off if you rent the car from Avis this weekend, for instance. So that is generating a lot of east-west traffic, all those things you do. And then you get this, oh, you're traveling with your wife. Do you want to buy champagne and chocolate to the room? And I have to click yes, otherwise it's damage control. So that is kind of east-west traffic. This is where the bad guys often hide. They do what's called a lateral movement. They get in there by using stolen credentials, or someone clicks a link and suddenly you have a malware. Now the bad guys knows that customers or companies have different tools to detect that. They will move east-west slowly, find kind of credit card data or personal records. When they have found the honeypot, as they say, they will simply steal the money, steal the data eventually, encrypt everything, and email the ransomware. Gigamon can help here and make sure that your NDR, like Vectra, for instance, will perform at the peak. I think I've been talking for quite some time now, and I think it would be very interesting to see the demo, and I think Pete still needs to be wired up. No? Well, anyhow, so with Gigamon, I just wanted to finalize this. Gigamon will understand and see east-west traffic because we sit on virtual machines, we sit on containers. You know how software developers are, they can spin up 200 VMs in 1 minute. Gigamon will sit there on each VM or container and we will follow it east-west and feed data to your existing tools. So, yeah. Pete.
Thank you, Marco. Okay, I better introduce myself. Marco did it, but I'll just reiterate. My name's Peter Connolly. I'm a sales engineer from Gigamon, based in the UK. Originally from Ireland. I hope my accent isn't too is clear and understandable. I tend to be a fast talker, as a lot of Irish people are. I'm going to try and slow it down. If I'm going too fast, please just give me the signal, because I can get a bit excited at times. What I want to do is put some flesh on the bones of what we've been talking about this morning and show you what the product actually looks like. I'm a visual person. When I can see something, I understand it a lot better. What we're looking at here is what we call our Gigamon Fabric Manager. Every company has a single pane of glass, so there's lots of single panes of glass. This is our single pane of glass. This controls the entire Gigamon environment, both physical, if you have physical products in your data center, but also all the virtual environments. And it lets you do various things: authentication, authorization, role-based access control. It lets you enforce policies and set up links into virtual environments, amongst other things. What I'm going to do is just show you the different environments that we work with. If we look at this inventory down here, we can see we've got a physical section, the different nodes. If you ever have a little orange box from Gigamon, or 1 or 2U orange box in your data center receiving traffic from taps, that's where these would be managed. But we also have the virtual environments. Now, we consider VMware, Nutanix, etc. to be private cloud. It's cloud by another name. So we have our virtual public and private cloud sections here. So we've got vCenter support, VMware NSXT support, third-party orchestration, which covers a multitude of clouds that aren't natively supported, Oracle Cloud, for example, Azure, AWS, Nutanix, and OpenStack. You'll notice down here we have a universal cloud tap these days, so we can reach into Kubernetes stacks and put a pod there and actually instrument those pods to receive traffic, send the traffic to us using what we call eBPF, if you're familiar with that technology. And that basically says, you as a pod send everything of interest to this Gigamon pod. So we can reach into those environments as well. If you're familiar with Azure, the IP address of the browser here, this is in the Azure environment. What I've done, I've just deployed the Fabric Manager in the Azure cloud. I've then created a connection. I've given it some credentials. I've said, you have the rights to reach into my Azure cloud and do things. Obtain traffic, look at the inventory of VMs that are running, find out the names, find out the tags, find out the IP addresses. You have the rights to do all that. You don't have certain rights, so you can't just destroy a production network. We're not giving it carte blanche to actually run riot around a production VNet. And what we can do there is give those credentials and then tell it how to obtain traffic. Now, every environment that we work in, so VMware, NSX, AWS, we try to obtain traffic in the native method. So, for example, in vCenter, it's using the distributed switch or the standard switch. In NSXT, it's using the APIs. In AWS, if you can afford it, we'll use VPC traffic mirroring. We have some people who will do a bit of both. They'll get the credit card out when they need to pay for VPC traffic mirroring, or they'll use our VTAP when they don't quite have that budget. So we tell it we have a method for obtaining traffic. This is called UCTV in the Azure environment. Some of these things you can tell are designed by engineers. You know, UCTV doesn't really trip off the tongue. It stands for Universal Cloud Tap for Virtual Machines. It's a VTAP, a virtual tap. Other people call it agents. We're not allowed to use the word. But that's how we obtain traffic in this environment. So we give the system the credentials to launch the plumbing, the cabling behind the scenes to reach into the Azure environment. The second part is to describe the policies. What do we want to do with the traffic? Right, we have the means to obtain traffic. What do we want to actually do with it? And this is where we create our what we call orchestrated flows. Again, we do it for each environment. You can cross traffic. You can send traffic to other environments. We have one customer. They're taking traffic from their VMware environment and they're sending it to a physical Gigamon box because they had invested in this physical. It's called a HC3. It's one of our largest traffic aggregators. But it does very clever things with traffic very quickly. So they said, we'll take all that virtual traffic and send everything to this box so we can actually see everything in one place. That's one possible approach. Another one would be for each environment to create a policy. And this is my simple policy. It's a very simple lab. There's 2 VMs running here, so it's not, I'm not burning the bills too much for Gigamon. And what I've done, I've told it that I want to do certain things with this traffic. And the first thing is filter it. Not every tool requires every packet or every byte of data. I used to work for an NDR vendor, and one of the quickest ways to kill a machine would just turn the fire hose of information. Okay, here's 2 spans from a core switch. Just send it to the NDR, and then value is instantly lost because it's just been trying to filter the wheat from the chaff. It's doing nothing clever. So the first thing we do is start to filter the traffic. And in this case, I'm not doing a huge amount of filtering. We have a rule set. You can see here, I've told it what rules I want. It's a very generous rule. If the IP version is version 4, you qualify. So any IPv6 is not going to go in. Any UDP, anything like that. So we just IP version 4. If I wanted, I could add rules and do ORs and ANDs and logical constructions to say, well, actually, I also need to see fragmented traffic, non-fragmented traffic. Or you might say, for example, if you scroll down here, VM tag source. Great in the cloud environment. We actually look at the tags on the VM. Does it say prod? Does the name begin with prod? Great, your production. We'll take your traffic. If it says it begins with UAT, we don't care. We're not going to take you. So we can start doing these logical constructions to filter down the traffic, and straight away we're getting down to the nitty-gritty of what we want to do. Actually, just excuse me for a moment. The next phase, once we've selected the traffic, is what do we actually do with that? We can do processing, and here I'm doing a bit of basic processing. This is called deduplication. It applies a lot in the physical environment. If you have a physical data center, you have lots of top-of-rack switches, and you've got flows going across them, a lot of the time we'll see the same packet multiple times. It'll change slightly, the MAC addresses and MAC source, MAC destinations as it gets switched around the data center. It's essentially the same packet. So sometimes you want to see duplicate packets. If you're measuring performance between switches, great, you see the performance and how it moves. If you're sending it to something that's reconstructing flows to look for bad intent, bad signals, you don't want to see 5 copies of the same packet. Just get rid of them. If it appears, if any of these characteristics appear, it says 5,000 milliseconds. If we use the same packet in 5 seconds, we will remove that. We just won't send it, we won't forward that. So straight away, sometimes you'll see reductions. I've seen 55, 60% traffic reductions just by getting rid of duplicates. Less relevant in the cloud environment, but can still be present as well. And in this case, I'm sending the traffic out in the first instance to a tool called NTOP-NG. Some of you will have seen it. It's a great open source tool just for visualizing networks. It's fine for validating just what am I seeing on my network. It's of very little cost. What I'm also doing, I'm sending a copy to Vectra instance. So what I did in the background is I stood up a Vectra brain and a Vectra sensor with the help of some of our colleagues from the UK who told me what I was doing wrong on several occasions. And then I created a tunnel to send this traffic. You can see the same traffic that we're acquiring here. So any IP version 4 is being sent straight out in a VXLAN tunnel to the IP address here. It's got a VXLAN network identifier and a port number, and that's it. It's done. When I deploy that, any of that traffic coming in on the left there, the pass-all rule, is going to go straight to Vectra. It's not a huge amount of traffic, as you'll see in a moment, but it's getting there. I have another rule, which I temporarily disconnected, which is I want to send data to Logstack. Same data, same network traffic, different use case. You've got different people. One, for the Vectra instance, it's the security use case. For Logstack, it might be performance, might be marketing. You just want to see actually what the use case there is. Here we're doing what we call application metadata. And application metadata basically says, I want to look at the flows that are coming in, and I want you to do deep packet inspection on those flows and actually send that traffic as a fragment of the full size. Don't send all the packets. Send the information about, for example, DNS entries. All the DNS entries that take place, send those details straight to Logstack, formulated as JSON, or it could be some other format that can be ingested by the platform. So we're sending typically 1% of the original data. Again, it's getting back to the point Marco made. How do we actually shrink the size of data to be managed and to be ingested into these tools? This is another tool that we have, the application metadata. And finally, we're starting to look at environments where we have applications, filtering at a higher level. It's great doing filtering at the level of ports, protocols, IP addresses, MAC addresses. That's fine. It's a bit 2005 for us. What we have is the ability to look at the flows and say, well, what type of traffic are you? In this case, most of the traffic is coming from one Ubuntu instance. As you can see, Ubuntu talks to itself a lot. I've been downloading an ISO in the background repeatedly. So about 25 megabits per second of traffic is just Ubuntu. Now, I don't want to send that to Vectra. Downloading an ISO isn't a bad thing. Well, depends on the ISO, I guess. If it's from Ubuntu, it's probably not a bad thing. Windows Azure traffic is the next most popular. That's management traffic for the Azure platform. Again, we don't want to send that to our NDR. So we exclude that. SSH, unknown SSL, the rest probably qualify. So what I can do is I can include them and say, all that traffic I will now send to Vectra. The rest, the vast majority, which is downloading of ISOs from trusted sources, I don't particularly care. It's not a threat to me. I don't consider it to be a threat. If the Ubuntu servers got compromised, that might be an issue, but so far we haven't been told of that. So while this has been going on, and hopefully it's still running in the background, I've got this lovely screen which is doing things on the network. Again, downloading traffic. This isn't very interesting. It's not meant to be stayed on for very long. But the net effect of running those few things is to give us threats that we can see within Vectra. So that traffic that I've just generated, that was gathered by the VTAP. It was sent across to what we call a V-series. A V-series is it's a VM that acts like one of our traditional orange boxes in your data center. That takes the traffic in, applies the policy that we saw drawn on, and then sends the traffic out to the targets. So that's what's going out here. We can see we've only got one host, but it's a critical threat, what we like to see. And in there we can go in and see that cryptocurrency mining has been going on since the early hours of this morning. And that is, I think at the start of this, I woke up at 5:05 this morning for some reason, and I thought I'd better fire it off once now, just to make sure it happens before I actually give the talk. And sure enough, it worked first time. I've been running it since then. But that's the case for every host that we have within your environment that you target. Once you've done that, we saw the pass all rule. Once you specify those rules, they're applied to all those workloads. It gets sent to the V-series, and then we tunnel it straight out. We never store anything. We're not a storage system. We can do PCAPs, but we tend not to. It's just for debugging. So it's down to the Vectra tool itself to do the analysis of the packets themselves. And that, in a nutshell, I can show you the NTOP NG, just to show you we're sending it to two different destinations at the same time. 10104 is that Ubuntu-based web server. You can see it's downloading as we speak in the background. One of the things that we find people like doing with our policies, I'll just wrap up on this one last point. When you create a policy like this and you're sending it to multiple destinations, because it's role-based access control, once it's done, network people can't interfere with security people's workloads. Security people can't interfere with network people's workloads. All of this, that's my map. I've done this using my identity. If somebody came along, they might be able to see this. They can't turn it off. They can't change it. They can't hide a host. They can't put an exception into that pass all rule. Pass all IPv4 except Peter's workstation because he's up to no good. So it's controlled. It's locked down. Like Vectra, we have an API. So I can go up here and I can integrate with the platform. I can spin all this up from something like Terraform, Bicep, one of those native languages for provisioning these environments. So it's controlled, it's secure, and I hope you'll agree it's very capable. So that's my quick demo that I got through without making too many mistakes. Is there any questions that anybody would like to ask?
Do we have any questions? No? Okay, then we have a few in online. My first question, maybe it's more, Marco, for you. You talked about OT and critical infrastructure. My question is, why OT monitoring can be so sensitive and difficult, and how Gigamon can help on this subject?
Yeah, that's a great question. So OT, operational technology, manufacturing, process industries. The thing is, you want to be completely passive in those environments. You can't run agents. Typically, you don't want to scan the network. So Gigamon can be completely passive and then feed whatever OT tool you may run with. Is it Nozomi or Armis or Clarity or something else? Another thing, when I looked at Pete's demo, we have been talking to a customer, and they are about to decide on which OT platform they want to, which OT platform do they want to buy. Actually, one of the use cases is they buy a small Gigamon and run the proof of concept, all three different tools in parallel. They know that is the exact same data that is hitting the different tools. And they can now look into that. Which tool is providing most value to us? That is kind of speeding up this proof of concept evaluation by weeks and weeks and weeks, because otherwise you might do one tool first, you try to follow protocol, tear it down, next vendor, and so on. So there are many use cases for Gigamon there. So yeah, absolutely passive. We take copies of traffic in motion and pass on to relevant tools. Might be an OT tool, but also might be your SIEM tool for correlation, stuff like that.
Okay. Also, our clients would like to know, they know that they can have a proof of concept with Gigamon. They can have demos, but do you have already clients in Estonia, and what is their experience with Gigamon?
Yes, we do have clients, and you're familiar with it. I actually can't talk about it. It's kind of governmental, and what they do is, simply put, let's say like this. They try to digitalize procurement cycles, because there's a problem that if those procurement cycles are not documented well enough, there's a risk of someone, taking bribes or whatever. I don't know, but yeah, that's an example. We have in the Baltic countries. I met last week with a large bank, for instance. They've been running on Gigamon on-prem for some years, super happy. But again, east-west traffic, the virtualized environments, and they also use a small degree of public cloud. So they will now add the Gigamon Cloud series to also understand the east-west traffic in virtualized environments. Actually, they believe that 70% of their traffic today is east-west. That's a lot.
Mm-hmm. Okay, thank you, Pete. Thank you, Marco, and amazing presentation.